Hello and welcome to a webinar on how to go to market with Meta. Let us start off by some practicalities. Today's webinar is going to be a bit longer than you're used to. So we're going to have about 60 minutes of presentation followed by a Q&A. Your questions are highly encouraged. For that, please use the question function that we have in the webinar platform. You are free to use the chat. We are always happy to see an active chat. But for the Q&A at the end, we will only consider questions that are submitted through the question function. If you have more questions after the webinar, you can always go to DevZone and get all of your questions answered. And a recording of this webinar will be available together with the presentations later on at webinars.nordicsemi.com/on-demand. This usually takes a day or two to be updated. We'll also include the Q&A from both the morning and the evening session of this webinar in the recording, so you'll be able to see all of the questions and answers. I am today's host. My name is Firmware Engineer. I'm a product marketing engineer here at Nordic. Today's speakers are Łukasz Duda and Krzysztof Loska. They are a senior firmware engineer and the technical product manager for Meta at Nordic.
Hello everyone, my name is Łukasz Duda. I joined Nordic almost 9 years ago and have been working on our Matter, Thread and 15.4 solutions since then. Currently, I'm leading our R&D team responsible for the Matter protocol.
Hello, my name is Krzysztof Loska. I work as the technical product manager at Nordic. I am responsible, among other things, for Matter and Thread technologies. I am also a member of Thread Group and Connectivity Standard Alliance Board of Directors.
If you haven't already, I highly recommend watching our previous Matter webinars. In the first one, you will learn about Matter from a specification perspective and see what Nordic offers for Matter product development. In the second one, you will learn how to develop your own Matter application using provided development tools. In this webinar, we will focus on the key aspects to consider when bringing your Matter device prototype into production. First, I will briefly describe how you can test your prototype device with the commercially available leading Matter ecosystems. Then I will present the various device firmware upgrade options that are available in the field. I will share some theory on Matter attestation and the distributed compliance ledger. And finally, I will demonstrate how to create a dedicated per device configuration in the factory. After that, Krzysztof will provide you with all the essential information about Matter product certification and the packaging of your Matter device. And of course, we will have a Q&A session. By the end of this presentation, you will have a better understanding of the steps necessary to move forward with production. So first, let's discuss how you can test your Matter product with the leading Matter ecosystems. Nordic's Matter over Thread and Wi-Fi solutions have been available for some time and have allowed the user to test its prototype device using developer setup. For example, as was presented on the previous webinar, you can use a command line tool called chiptool on your Linux or macOS machine to simulate a Matter controller and Raspberry Pi to set up a Thread border router. This testing approach is of course still useful, for example to test a new cluster in the data model. However, it requires some work and knowledge to set it up properly. And it does not reflect the real experience of users of your product. Fortunately, testing Matter solution has become much easier thanks to the official support for Matter in on-market products. So right now, what you need is just your prototype device or Nordic's development kit and devices from at least one of the ecosystems compatible with the official Matter implementation. The NRF Connect SDK follows the most recent versions of the Matter protocol and is interoperable with several commercially available Matter ecosystems. For example, with Google Home, Apple Home, Samsung SmartThings, or Amazon Alexa. Support for certain functionalities and device types, however, differs between ecosystems. Recently, we have released a new blog post on the DevZone that presents a step-by-step guide on how to commission the simulated Lightbulb Matter device using Thread and Wi-Fi transport with multiple ecosystems. Currently, this guide presents how Nordic's DKs can be commissioned and controlled by Google Nest Hub Second and Google Home App, Apple HomePod Mini and Apple Home App, and finally IoTech Smart Home Hub and SmartThings app. Thanks to the multi-admin functionality, the Matter accessories can be controlled by all the ecosystems simultaneously. The ecosystems list is not limited. You can test your prototype device, for example, with Amazon Alexa devices as well. Now let's discuss device firmware update. As a product maker, you will likely want to update the firmware of your devices at some point during their lifespan. For example, when you extend the feature set, update the Matter or underlying stacks, find a bug, or discover a security vulnerability. The Matter protocol itself requires each device to have the capability to update its firmware. Additionally, the DFU process itself must meet certain security requirements. Using NRF Connect SDK, you have a few options for performing firmware updates. First, you can use the DFU or OTA process, defining the Matter specification over IPv6. Then, you can also use our standard DFU over Bluetooth Low Energy. I will demonstrate both of these DFU options in a moment. If you are building a product with a 2-chip architecture, you may want to consider using DFU over a serial bus like UART. Additionally, since Matter uses IP technologies like Thread and Wi-Fi, there is nothing stopping you from having your own proprietary DFU mechanism where your devices directly communicate with the cloud. All Matter example applications in the SDK come with an immutable, optionally upgradable bootloader called MCU Boot, which helps with image swapping and secure boot. Also, do remember that to support DFU using NRF52840 or NRF5340, you need to have external flash memory connected over QSPI or SPI, which is used only to download a new image. The DFU over Matter, sometimes called Matter OTA, is a process that allows a Matter device in a Matter fabric to update its firmware. Such a Matter device acts as an OTA requester. The new software image is provided by another Matter node called the OTA provider, which downloads it on behalf of the device from a reliable source, such as your cloud or a dedicated hosting server. The OTA provider may use the CSA database called DCL, which I will describe later on, to obtain the URL to the new image for the specific device. The download itself takes place over a special Matter-defined transfer protocol called BDX that operates over the Matter label protocol on top of UDP. Overall, you can think of this process as a background DFU process that happens automatically without user intervention, although user consent is usually required for the final phase, which is applying the downloaded firmware to the target Matter device. It's worth mentioning that when you compile a new firmware for your device, our build system in NRF Connect SDK automatically generates a binary image with the signed firmware and prepended required Matter OTA header that you can use in production. If you want to use DFU over Matter in your application, let's see how to test it in the development environment before moving to production. For the DFU over Matter demonstration, let's use Matter door lock sample from NRF Connect SDK built for NRF 7002 DK. This development kit includes our new Wi-Fi chip. The stock firmware version of door lock is already flashed into the device, which is connected to my PC. What I'm going to do right now is to prepare the new firmware image that will replace the old one. For this purpose and simplicity, let's just add a new lock, which will be printed right after application boots. Before we can build the new image, we need to remember to properly configure versioning. This is because the firmware package using the DFU over Matter process must include a Matter-defined header with fields describing the firmware itself. Let's configure the sample by modifying a product.conf file. I'm going to use firmware version 2 and its corresponding string. Now let's rebuild the firmware and wait a bit. Okay, the build process has been completed. Finally, as a result, the matter.ota file is generated by the build system itself, which we will use during DFU over matter process. This file combines both application and network core images. Let's now jump into the console to see how to test the matter over DFU solution. In this demonstration, I will use development tools, but feel free to look at the documentation of the commercially available Matter ecosystems to see how to test the Matter OTA. On the left-hand side, you can see the output from the UART logs printed by the NRF7002 DK. This device has not yet been commissioned to the Matter network. On the right-hand side, we can see the window for the OTA provider that will be simulated on the PC, and on the bottom for the Matter controller, which will use chiptool application. Note that in the production environment, those two roles will be most likely combined in the Smart Home Hub. As was presented on the previous webinar, to simplify the development and testing process with NRF Connect SDK platform, with each release, we do deliver pre-compiled versions of both chiptool and OTA provider applications. First, let's run OTA provider application and choose the newly generated matter.ota file, which you can find in the build folder. Okay, as OTA provider simulates a normal Matter node, let's commission it to the Matter network and let's assign the node ID 1. Okay, since this is done, let's now push button 2 on the DK, which opens the commissioning window for this node. Now we can commission our NRF7002 Matter over Wi-Fi device to the Matter network. Let's assign a node ID 2. Also note that I'm using SSID and password to my local Wi-Fi access point. Okay, commissioning has been completed. Let's just verify that we have communication with the node. For example, by reading its vendor name. Okay, and we see the Nordic Semiconductor ASA value in the response. Before we can start sending a new image, we need to also configure access control list on OTA provider node to allow receiving cluster commands from the OTA requesters. Now, let's trigger the Matter OTA process by sending an announcement. As we can see through logs, the uploading process has been started. Now we need to wait for its completion. The new image has been uploaded. Now the accessory device needs some time to swap the old image with the new one. And finally, we can see the new log in the console. So device, again, associated to the Wi-Fi network, and also send notification to the OTA provider that DFU process has been successful. As previously mentioned, you can use our DFU over Bluetooth LE solution in addition to, or instead of, the previous DFU method. With this type of DFU, you can change the firmware of a device via Bluetooth LE connection using a mobile phone or PC with dedicated software. One advantage of this method is that you can immediately start the DFU process with the targeted device. In the DFU over Matter solution, the update happens more in the background and may take some time to be initiated. We have integrated this feature with our Matter samples as optional feature, and enabling it requires adding an additional kconfig flag called cheap DFU over BTSMP while building your application. Nordic Semiconductor also develops the NRF Connect Device Manager mobile application as an open source project on GitHub for both Android and iOS, making it easy to integrate the DFU functionality into your vendor-specific mobile application. Similarly to the previous method, our build system automatically generates a file that includes the signed firmware and SMP metadata. The DFU package is called dfuapplication.zip. On the right-hand side, you can see the simple workflow of the DFU over BLE mechanism, which involves connecting to the device that advertises over BLE, then selecting the new firmware package, and finally starting the upload process. In this demo, I'm using the NRF5340, which has two cores, so the image upload is divided into two phases. After uploading is complete, as it is right now, we need to wait for the bootloader to swap the image. Yes, and finally, we can see that the device advertises a new name with v2 string at the end and still responds to the SMP commands. Let's start with the concept of Matter device attestation. Matter not only defines a common communication language between devices, but it also aims to address some of the most pressing issues in the current smart home market. One of them is presence of counterfeit products. As smart home owners, we want to be sure that the products we buy are legitimate and certified and do not pose a security or reliability risk. To address this, Matter introduces a device attestation procedure as a dedicated step in the commissioning process. During this step, a commissioner application, typically on a mobile phone, cryptographically verifies that the device is a genuine product. The device attestation process is based on the chain of trust concept and is mandatory for all Matter devices. Therefore, devices include a special unique certificate called a Device Attestation Certificate, or DAC for short, to protect against counterfeits. Additionally, each device has a certification declaration document used to verify Matter compliance. Now let's discuss how devices are attested. For this purpose, Matter uses a well-known public key infrastructure scheme, PKI, which you may be familiar with from browsing the internet. The device attestation PKI hierarchy consists of the Product Attestation Authority, PAA, Product Attestation Intermediate, PAI, and the previously mentioned Device Attestation Certificate, DAC. So the PKI certificate chain always includes exactly 3 certificates. The PAI certificate is a self-signed root certificate. In Matter, we may have more than one root PAA, and all of them must be strictly vetted by the CSA. Certificates must be then placed in the CSA database called the Distributed Compliance Ledger, which I will discuss later. In practice, such certificates are generated by the digital certificate provider or the product manufacturer that wishes to maintain the PKI infrastructure. PAA certificates can optionally be limited to issuing PAI certificates only with a certain vendor ID. Next in the chain is the Product Attestation Intermediate, PAI, which is an entity that is directly responsible for issuing device attestation certificates. As you can see, the PAI is limited to generate DAGs with a certain vendor ID and optionally a fixed product ID. At the end of the chain is the DAG, which is a regular X509 compliant certificate that must be unique across all individual devices. The certificate includes parameters such as the product ID, vendor ID, and its serial number. Each Matter device needs to be configured in the factory with a DAG and corresponding private key, as well as the PAI certificate. It is very important to keep private keys secure, whether on the device itself, in the case of the DAG's private key, or on the specialized hardware security modules for the PAI or PAA private keys. What is important to note on this slide is that as a product maker, you need to provide individual DAG certificates to your devices. Currently, you have two primary options for generating unique device attestation certificates. First, you can work with a CSA member that is an established PKI provider and offers PAA services. Typically, PKI providers may provide you an encrypted file containing pre-generated DAGs in a secure manner, which you can later flash onto your device in the factory. They may also offer an online service or a dedicated HSM device to generate certificates on demand, or even provide full secure provisioning services. The second option is to maintain your own PKI. If your organization wants to create one or already has an existing PKI that is used, for example, for code signing or other tasks that rely on asymmetric cryptography with certificates, it may be possible to use it to support the issuance of DAGs for your product. In all cases, the PAA providers, either you or a third-party company, needs to comply with a Matter certificate policy requirement, which you can find in the CSA resource kit, which is available for CSA members. After obtaining the DAGs, our solution in NRF Connect SDK offers an easy way to program them into device in the factory. Without going into too much technical details, the device attestation process is performed during Matter commissioning before the device is granted credentials for our Thread or Wi-Fi networks. This prevents unauthentic devices from being added to the network unintentionally. In general, the commissioner verifies that the DAG chains back to one of the trusted PAAs in the CSA database, and most importantly, that the device is in possession of the DAG private key. Verifying the PKI certificate chain ensures that the device is a legitimate Matter device from the given manufacturer. However, it does not provide any information about the certification status of the device. Matter certification guarantees that after joining the network, the device will function according to the Matter specification and will interoperate with other Matter devices on the network. After you pass Matter certification with your product, you will receive a certification declaration, CD, from the CSA. It is a statement signed by the CSA PKI stating that the product identified by a vendor ID, product ID, and the software version has passed Matter certification. Since the CD is unique only to the product and firmware version, rather than each individual product, you can simply store it together with your application in the firmware. To do that, you can simply override the chip device config certification declaration defined in your chip project config.h of your application. Let's now explain the concept behind the CSA database called the Distributed Compliance Ledger, or DCL. The DCL is a distributed database that is cryptographically secured using blockchain technology. This database is distributed across many servers located around the globe and hosted by CSA members. The DCL stores information about Matter products and their compliance status. This is useful for a few use cases. First, vendors can provide information about their products, such as the product name, URL to instruction, custom commissioning flow, or information about any firmware that is available. Secondly, the CSA and authorized test laboratories can update the certification status of products. Both vendors and the CSA can coordinate the publishing of information about the products, for example, to coincide with the product launch date. Finally, as previously discussed, the DCL is also used to store all approved product attestation authorities certificates, which are used by the commissioner to verify the certificate chain. As a device maker, you should add information about your product to the ledger before you ship it to market. Without this step, some Matter ecosystems may not allow commissioning your product. One convenient aspect of the DCL is that you can easily add an entry to the database using a web UI. However, it is also possible to use command line tool for this purpose, for example, to automate your deployment process. So let's take a look at the DCL UI web page. To add an entry to the DCL, you must first create an account that will be approved by CSA members. To speed up this approval process, you can reach out to CSA members in CSA Slack channel called a DCL enrollment. Once your account is activated, you will be able to add a vendor information, product information, including information about the firmware updates, check the compliance status of your device, and view the list of all approved Matter product attestation authorities. You can also get familiar with command line tool to interact with DCL, which you can find in the Zigbee Alliance GitHub account. Let's jump to the factory provisioning. Most likely, all of your Matter products identified by the same vendor ID and product ID will be flashed with the same firmware. However, there are a few use cases in Matter where we need to have a dedicated, unique, or pseudo-random values per device. We collect them together, creating what we called factory data, which is written alongside the application firmware. The factory data includes different types of information, such as device certificates, cryptographic keys, device identifiers, or hardware description. All of these parameters are vendor-specific and must be inserted into a device's persistent storage during the manufacturing process. Factory data parameters may be used by both the Matter stack and the user application. For our platform, the factory data is stored by default in a separate page of the internal non-volatile memory, which helps to keep the factory data secure through hardware protection. Note that factory data partition differs from non-volatile memory settings partition, where the data inside changes during device lifetime. NRF Connect SDK comes with handy utilities which allow to create and flash factory data into non-volatile memory. So let's try to use them. Before we begin generating and flashing factory data onto the device, let's first familiarize ourselves with the contents of the factory data. You can find detailed documentation about it in our NRF Connect SDK documentation, which we will use also during this webinar. So first of all, let's go to the factor data component table, which presents a list of currently supported parameters. We will go through a few of them. For example, it is possible to configure the vendor-specific unique serial number of the manufactured device. We have the vendor ID assigned by the CSA. We have a product ID assigned by the product maker. We also have a few fields presenting human-readable vendor, product, and hardware identification. There is a unique ID for the rotating device ID, which is used to identify the specific device for the Amazon frustration-free setup technology. We can also see the DAC certificate and accompanying private key, as well as the PAI certificate. Then we also have parameters needed for the device discovery during the commissioning process. So we can see fields related to SPAC2 verifier, which is basically a result from the key derivation from the passcode. Additionally, we have the discriminator, which is used by the commissioner to properly find the device which we want to commission into a Matter network. By default, support for the factor data is disabled to allow for quick prototyping, where such parameters can be set using kconfig values. However, on the production line, this approach would not work, as after changing even one of the parameters, you would need to recompile the entire firmware. So let's see how to enable factor data support. So as you can see, to enable it, we just need to add one extra kconfig, which we will use in a second. So let's copy it. Let's now jump into the VS Code with the NRF Connect SDK extension and try to compile the Matter example application with the factor data module enabled. Let's start with creating a new application. We will use Matter Lightbulb as a reference application template. Then let's create a configuration. Also make sure to enable factor data support. And let's build our sample. Okay, the sample has been built. Let's now flash it into the NRF52840 DK. Okay, programming has been completed. So now let's try to open the terminal window to see the debug logs from the device. To do that, let's open the serial port. Okay. And as we can see, the application did not boot. This is because we have not yet provided factor data parameters to the factor data partition. I have created here a small bash script based on the NRF Connect SDK documentation, where we can see two Python scripts. The first one creates the intermediate JSON file based on the parameters given by the product maker, like the serial number, hardware version string, certificates, or discriminator. The second one takes the JSON file and generates the binary file, which can be flashed directly into the specific area of non-volatile memory storage using, for example, NRF JProc. So let's now try to run it. We can see this time that the device is fully operational and all parameters match with configured values. Let's do one quick adjustment. for example, with the discriminator, and let's say serial number. And let's run the script again. As you can see, changes are reflected in the debug logs. Please note that mechanism that I have presented may be replaced with your own. This is described in the last section of the documentation. And essentially, the Matter stack requires a few functions to be implemented by the application, which can be adjusted to your specific needs. Finally, I would like to list a few things to consider before releasing your product. First, make sure to use your own private key to sign and validate images in the DFU process. Please note that for simplicity, all example applications in the SDK use development keys. I encourage you to follow the step-by-step instructions in NRF Connect SDK documentation on how to generate and use your own keys. Secondly, you may want to disable all debugging capabilities, such as reading content of the internal memories. This can be achieved using our hardware access port control mechanism called appprotect. And likewise, please check the documentation in the SDK to see how to configure appprotect, for example using dedicated kconfigs or nrfjproc commands. In addition, if you use debug serial port, please consider turning it off. This ensures that no sensitive information can be accessed by an attacker. Finally, Matter uses non-volatile memory settings to configure some dynamic parameters like network information or key counters. By default, all Matter samples are configured with 16K of flash memory for this purpose. If your application heavily uses non-volatile memory for other purposes, you may want to measure memory utilization and potentially increase the settings partition to reduce a flashware.
Okay, thanks a lot, Łukasz. And then it's time to talk about product certification and how to certify a Matter device. For that, we'll be hearing Krzysztof Loska.
Certification is an important part of the product release process. There are many combinations of membership levels and certification paths. In this presentation, I will try to recommend the simplest and the cheapest combination to release your first Matter product to the market. The set of certifications you should perform depends on the type of device. Matter is only an application layer, so to release Matter devices to the market, Matter certification alone is not sufficient. In addition, you need to perform certification of the transport layers. So if you plan Matter over Thread device, you should plan to also perform Bluetooth LE qualification and Thread certification in addition to Matter certification. If you plan Matter over Wi-Fi device, in addition to Matter certification, you should also plan Bluetooth LE qualification and Wi-Fi certification. And if you plan a dual Matter device, which combines both Matter over Thread and Matter over Wi-Fi, or you maybe plan to build a smart home hub, which combines Thread border router and Matter controller, then in addition to Matter certification, you should also plan for Bluetooth LE qualification, Thread certification, and Wi-Fi certification. The Bluetooth SIG offers two levels of membership, Adopter and Associate. The Associate level gives you a greater influence on Bluetooth technology by enabling you to work in working groups and influence emerging specifications. For an easy start, I recommend to become an Adopter member, which has no annual membership fee, but you need to consider what is more cost-effective for your business. As you can see here, the declaration fee for the Associate level is twice as low as for the adopter level. So if you plan to certify multiple devices, it may be more cost-effective to be a member at a higher level. So what are the most important reasons to do a Bluetooth qualification? The Bluetooth qualification process promotes global product interoperability. So you ensure that your device will be compatible with other devices using this technology, such as smartphones. But above all, Bluetooth qualification gives you the right to use Bluetooth patents, trademark, and logo. The Bluetooth SIG clearly states that all Bluetooth products must be qualified. It is not enough to just reference the qualification from your supplier. You must complete the qualification of your product for yourself. You can familiarize yourself with the details of the Bluetooth certification using the link provided at the bottom of the slide. Bluetooth offers two qualification paths. The first one is referred as qualification process with no required testing. This path is applicable when you use another member organization's previously qualified Bluetooth end product or subsystem in your product with no changes or additions to the Bluetooth design. You can also use this path when you purchase a Bluetooth product manufactured by a third party and distributed with your organization's name or logo. It is also referred as white labeling. You can also use it when you create combinations involving only previously qualified end products or subsystems and you make no design changes. The second certification path is referred as qualification process with required testing. This path is applicable when you create a new design or combination that does not involve only previously qualified Bluetooth end products or subsystem. It is also applicable when you alter a previously qualified Bluetooth design by changing the core configuration or functionality. This path is also applicable when you qualify a design that uses a previously qualified Bluetooth component product type, rather than a full qualified subsystem. The easiest and the most common path to obtain Bluetooth qualification is to use qualification process with no required testing. Every release of NRF Connect SDK provides two qualified components. Qualified Bluetooth LE controller subsystem, which we call the soft device controller, and qualified Bluetooth LE host subsystem, which we inherit from Zephyr RTOS. If you use them in your Matter product, you can reference Bluetooth LE QDIDs obtained by Nordic to apply for Bluetooth LE qualification without testing. Thread Group offers 5 levels of membership: academic, affiliate, implementer, contributor, and sponsor. The contributor and sponsor levels allows the greatest impact on the thread technology. Only members of those levels can participate and vote in work groups and committees to influence emerging specifications. Members on the sponsor level additionally sit in the board of directors and drive strategy of the organization. For an easy start, I recommend to join the organization on the implementer level. which has lower annual membership fee but still allows to certify your devices by inheritance. So what are the most important reasons to do a thread certification? Thread certification provides a formal validation of the product's conformance to the thread specification and the product's interoperability with leading thread reference implementations. So you ensure that your Matter device will be compatible with other devices using this technology, such as smart home hubs. A certified thread product also acquires a product license for intellectual property rights to the thread technology. Without certification, your product violates the patents used in thread specification. Finally, a certified thread product acquires license to use the thread group certification logo with the product. You can familiarize yourself with additional details of thread certification using the link provided at the bottom of this slide. Thread offers two certification paths. The first one is referred as certification by inheritance. You can use this path for derivative products. This is typically the simplest scenario, which applies for variations of certified product, typically within a member's own product family, or to certify a device which got non-thread functional changes, cosmetic changes, etc. This path is also applicable for use of a certified system, so stack and chip combination within a module. And finally, this certification path can also be used for end products, but this is the most complex scenario. In this variant, thread certification by inheritance is used to reference a certified system, so a combination of hardware and thread stack, within an end product. Feasibility of this scenario is dependent on specific vendor stack deployment approach and may require extensive supporting technical information. But please stay positive. Nordic delivers all needed technical information and technical support, so you can use this path for your product. The second certification path is referred as certification at an authorized test laboratory. This path is applicable when you use an uncertified thread stack or when you change a thread certified component. The easiest path to obtain thread certification is to use thread certification by inheritance. Every release of NRF Connect SDK provides pre-built open thread libraries certified as thread certified component. If you use thread certified component provided by Nordic, your Matter product can reference thread CIDs obtained by Nordic to apply for thread certification by inheritance without testing. You can find more details in our documentation within NRF Connect SDK. On this slide are the fees for thread certification to give you an idea of the cost. Recertifications, which are free of charge, apply for products which change some non-thread related software. For example, if you do a device firmware update which only changes Matter related code but leaves thread stack unchanged. Wi-Fi Alliance offers two levels of membership. contributor, and implementer. As in other standardization organizations, the higher level, which is the contributor, gives a greater influence on the technology by enabling participation and voting in marketing, technical, and regulatory task groups. But there is one important difference you need to consider, and the reason I cannot recommend any level here. The lower level, which is the implementer, only allows you to use in your product unmodified Wi-Fi modules which have been certified by another member. Therefore, if you plan to design a custom board around a Wi-Fi integrated circuit rather than use a module, you have to join the organization at the contributor level. The reasons to do a Wi-Fi certification are similar to other certification programs. Certification means that the product has been tested in a variety of ways to validate interoperability with other Wi-Fi certified equipment operating in the same frequency band, such as Wi-Fi access points. Wi-Fi certification is also a prerequisite to use the Wi-Fi certified logo and Wi-Fi certified certification marks. Wi-Fi offers 3 certification paths. The first one is referred as Flex Track. Flex Track is tailored to highly differentiated products designed from the ground up. Flex Track allows extensive flexibility in product design, including customization and optimization of Wi-Fi functionality. This track is not required for an end product based on qualified solutions. For an easy start, I recommend Quick Track or derivative paths. Quick Track path is tailored to end product based on qualified solutions that have already completed Wi-Fi core and conformance testing. Quick Track is the latest certification path launched by the Wi-Fi Alliance, which was designed to lower certification costs and to reduce the time to complete certification testing. Derivative path is applicable if there is no change to the Wi-Fi capabilities of an end product based on another Wi-Fi certified end product. This is typically the case for end products created using Wi-Fi certified modules. This path could also apply to an end product adaptation of an existing Wi-Fi certified product. You can find more details regarding Wi-Fi certification following the link at the bottom. Derivative certification is the easiest path to obtain Wi-Fi certification if you plan to use a third-party Wi-Fi certified modules containing an NRF 70 series IC without any modification. A range of module suppliers offer qualified and certified modules based on Nordic semiconductor technology, and the link at the bottom provides a comprehensive list of them. If you plan to build a custom board around NRF 70 series integrated circuit, Quick Track path is the fastest path to obtain a Wi-Fi certification. Soon, NRF Connect SDK will provide qualified solutions and qualified solution variants for all NRF 70 series platforms. If your Matter product uses them, you can reference Wi-Fi CIDs obtained by Nordic to apply for Wi-Fi certification of an end product through the Quick Track path. Quick Track path allows targeted modifications to Wi-Fi components and functionality, but always a subset of tests is required. At the bottom of the slide, you can find the link to Nordic's white paper, which discusses in details all aspects of the Wi-Fi certification programs. On this slide are the fees for Wi-Fi certification with which you can familiarize later. So you might ask where to find qualification IDs and certification IDs for particular SoCs and particular releases of NRF Connect SDK, which you can reference to. Those kind of information you can find on Nordic's InfoCenter portal. As an example, you'll see the documentation of NRF 5340 SoC. In the compatibility matrix section, you can find references to all applicable certifications and qualifications obtained by Nordic. And as an example, you see thread certification IDs for all applicable NRF Connect SDK releases. Connectivity Standard Alliance, which among other technologies governs Matter, offers 4 levels of membership: promoter, participant, adopter, and associate. And again, as in other standardization organizations, the highest levels, which are promoter and participant, give a greater influence on the technology by enabling participation and voting in alliance working groups, enabling participation in the development of market messaging and marketing communication, and so on. Members on the promoter level additionally sit in the boards of directors and drive strategy of the organization. Associate level has a special purpose and is intended for organizations which would like to white label or rebrand already certified product. For an easy start, I recommend to join the organization on the adopter level, which has lower annual membership fee but still allows you to certify your Matter device. You can find more details following the link at the bottom. When you completed certifications and qualifications of underlying transports, you can start Matter certification. Matter certification denotes compliance to the specification and validates interoperability. In addition, certification allows the use of certified product logos and lists of the product on the Alliance website for verification. I would like to emphasize that Matter product certification cannot be inherited from a semiconductor vendor. As a result, first Matter certification of a product always includes testing at an authorized test laboratory. You can read more about Matter certification following the link at the bottom. Now let's look into details of the Matter certification process. As with dependent certifications, before you start applying for a certification, you must join the respective organization, which is a membership at CSA for Matter certification. Joining CSA allows you to apply for assignment of vendor ID, which is required when applying for a certification. The Matter certification process requires testing before any application for certification is sent. The testing can be performed at an authorized test laboratory using a test plan developed by CSA. Each ATL has its own submission process, but all require a declaration of conformity and a protocol implementation conformance statement, or in short, PICS. Both documents confirm that the Matter end product you are going to certify is meeting the protocol requirements. After the Matter component successfully passes all test cases, the ATL sends a test report to both you and CSA. Once you have obtained the test report for your Matter end product, you can apply for certification to CSA. The final application for certification requires you to send the following documents to CSA: Declaration of Conformity, PICS, Dependent Transport Attestation, Matter Attestation of Security, and description of the Matter end product to be certified, including photos. During processing stage, CSA verifies the submission for relevant criteria, including relevant documentation, membership in CSA, completion of testing, and payment of the applicable fees. At the end of a successful processing, your Matter end product is granted the certification. The standard Matter certification process has several variants that you can use if you have already obtained the certification or you want to certify several products of the same family. So we have rapid recertification program, which can be especially interesting if you would like to provide a device firmware upgrade for your Matter device. We have product family certification and we have certification by similarity. You can familiarize with more details regarding those variants following the provided link. So what does Nordic do to facilitate your Matter certification? We perform exhaustive verification of Nordic's Matter solution for every NRF Connect SDK release. We guarantee that every release of NRF Connect SDK passes all applicable core Matter certification tests. We also provide comprehensive documentation regarding Matter certification as part of NRF Connect SDK documentation. And last but not least, we have also prepared and provide certification document templates, which you can request and obtain by opening a private ticket on Nordic's DevZone portal. On this slide are the fees for Matter certification. Please note they do not include payment for testing services to an authorized test laboratory. Let's take a moment to talk about product packaging and branding. Compatibility badges are a quick and easy way for consumers to gain confidence that the devices they are buying will work with each other. You already know that to use them, you have to obtain respective qualifications and certifications. On the side of the slide are links to all relevant brand and setup guidelines. Please note that Thread has separate badges for Thread border routers and end devices. Matter over Thread end devices should carry the Thread badge with the requires border router mark to help consumers know they will need a Thread border router, often built into many smart home hubs and devices. An important part of product design is the consideration of space for a Matter setup code. Matter makes smart home device setup easy by standardizing the setup process with a consistent set of steps. Matter devices use Bluetooth Low Energy and numeric, QR, or NFC setup codes to make this process consistent, easy, and secure. You can find more details regarding design of Matter setup codes following the provided link. To summarize, I would like to point you to very important resources. The first is NRF Connect SDK documentation for Matter. It includes several user guides such as Matter Overview, Getting Started with Matter, or How to Create Matter End Product, which was the topic of today's webinar. The second is Matter Resource Kit, which is part of Connectivity Standard Alliance member portal. It provides references to all documents related to Matter, including brand and setup guidelines, specification, distributed compliance ledger, product attestation, certification, and so on. This was the last slide of today's presentation. I wish you good luck with the release of many Matter products based on Nordic SoCs.
Thanks a lot, Krzysztof. And with that, we are done with today's presentation and can go over to the Q&A. Let's have a look.
Thank you, Finn. There are quite a few great questions. So let me start with first two of them. So the first one is, what are the device types supported by the ecosystems? Can I try with the door lock? So to get the latest information on the supported device types, I would recommend to check the documentation provided by the Matter ecosystem provider. Links to the documentation of some of the leading ecosystem providers can be found in our NRF Connect SDK documentation. But in general, the list of supported device types may vary between ecosystems. But as for door locks, they are currently supported by Google Home, Apple Home, and Samsung SmartThings. The next one is, I have tried commissioning the light switch Matter sample with Apple HomeKit, but it says that the device type is not supported. Are there any plans for making this sample compatible with Apple HomeKit? So in general, this is expected. As far as I know, currently Apple HomeKit does not support light switch based on the switch cluster that uses binding. It does, however, support generic switch with a limited set of features. I'm not aware of specific plans for supporting binding-based switch cluster in Apple HomeKit. I think this question might be asked directly to Apple. Krzysztof, can you take a few other ones?
Yeah, sure. So one of the question is, do I need to do any certification if my product won't use any logos? Yeah, so here there are some risks involved that you should consider. Typically, certification provides a product license for intellectual property rights to the technology. So if you do not certify your product may violate patents incorporated in a technology. Another related question is, if I want to cut costs and do not want a Bluetooth or Thread logo on the box of the product, but want to certify with Matter, is it mandatory to become Bluetooth and Thread member? Yes, so underlying transport certifications are prerequisite for Matter certification. So this is being checked as part of a verification process as a prerequisite steps for Matter certification. So your Matter certification form will not be accepted if you do not provide an underlying transport certifications. Another question is on the first qualification path, what means no design changes? What is the definition? Yeah, so it might differ slightly from organization to organization, but generally it means that you should not introduce any changes to the protocol stack. So, for example, for Bluetooth and for Thread, we deliver as part of NRF Connect SDK a pre-built libraries for Bluetooth protocol stack and for Thread protocol stack. And you should not introduce any changes into them to be able to reference our qualification or certification.
Okay.
Łukasz?
Yes, let me now try to answer a few DFU-related questions. So the first one is DFU support a mandatory requirement for Matter? And the answer is yes. This is one of the security requirements imposed by the Matter specification. Basically, as a product maker, you need to either use DFU over Matter, defined in the spec, or other proprietary means, like DFU over BLE. The next question is, DFU over Matter network was performed via Wi-Fi. Is it possible to perform a DFU over Matter update over Thread? Yes, so basically Matter protocol runs on the transports which are IP enabled, like both Wi-Fi and Thread. And more specifically, the DFU packets are sent over UDP, used by the Thread itself. And as a result, DFU over Matter is supported over Thread. The next one is how the OTA provider knows that device needs a new firmware. So in the DFU over Matter, the OTA requester is responsible for initiating the update process by querying the OTA provider periodically. So this is done to check for the availability of new software images. During these queries, the OTA requester includes information such as the vendor ID, product ID, and the current software version of the device. And based on this kind of information, the OTA provider can easily determine whether a new software update is required by looking at the DCL database. And maybe one more. Can DFU over Matter use global IPv6 or is only supported over NAT? So basically the DFU over Matter always include the intermediate node called OTA provider, which is part of this Matter network, local Matter network. And as a result, the IP communication with the Matter node happens using local IPv6 address called ULA. In case you would like to have proprietary DFU solution where device connects to the third-party cloud to download a new firmware image, then using NAT or not depends on the home network architecture, like availability of IPv6 global prefix. Okay, Krzysztof?
Yes. So another question related to certification is, for example, if I use certified my new BLE module based on NRF 52840 and release such a product, do we need any additional certification for BLE? Is there any additional accept to BLE certifications? So it is very simple to inherit certification from Nordic, but the answer is yes, you have to apply for Bluetooth qualification. So as was stated in the presentation, it is not just enough to inherit the certification from your vendor. You always have to apply for Bluetooth qualification or Thread certification or Wi-Fi certification. You can reference our certification and use a simplified path to obtain qualification without testing or to inherit our Thread certification without testing. But you always have to apply for this to the right organization. You always have to pay certification fees and so on. Another question is related to length of the certification. So how long is the BLE, Thread, Wi-Fi, and Matter certification? Let's say I have already complete product. Yeah, so this depends on the certification path which you would like to use. If you would like to have full testing at an authorized test laboratory for all protocols, it can easily take several months. If you want to use simplified paths for Bluetooth and Thread and Wi-Fi, this probably takes several weeks. Plus, I would say several weeks for Matter certification, because, as mentioned in the presentation, first Matter certification always involves testing at an authorized test laboratory. So I think I would reserve at least like 2-3 months to complete all certifications, all documentation, and so on. And the last question regarding certification is related to a specific ecosystem. Do specific ecosystems require Matter certification relating to the ecosystem? Yeah, so Matter-based ecosystems like Amazon Alexa, Google Home, Apple HomeKit, Samsung SmartThings, they do not require additional certifications beyond like Bluetooth, Thread, Wi-Fi, Matter certification to be able to connect Matter devices and to be able to use them together with an ecosystem. However, some ecosystems deliver some additional functionalities, and one of the examples is Amazon Alexa, which delivers additional functionality called frustration-free setup, which is not part of the Matter specification, but is something specific to this ecosystem. So then, if you would like to use some extensions of Matter, which are proprietary to one ecosystem, then you have to apply for an additional certification to this ecosystem provider, in this case, Amazon.
Now I have a question. Device attestation certificate. Does it really need to be unique? So the answer is yes. That must be unique for each of the product or Matter device. This is to prevent cloning or replication of the device. In Matter, it's the ecosystem provider who can discover that there is more than one Matter device connected with the same DAC. And there's one more question on the chat. Is DFU sample available in GitHub? So yes, all reference Matter samples in the NRF Connect SDK have DFU over Matter support enabled by default. And DFU over BLE can be enabled optionally. So in essence, yes, on NRF Connect GitHub project, you can find the Matter samples showcasing DFU.
Okay, I have another question related to modules and certifications. So the question is, if I sell our Matter certified module based on Nordic platform, should the end customer certify again their product for Matter? And the answer is yes, they have to certify for our underlying transports and for Matter, but they can use these simplified paths, right? So they just can reference your certification or Nordic certification, use qualification with no testing, use certification by inheritance for Matter. Also in Matter certification, they maybe could use some simplified path, even without testing, like certification by similarity. But yeah, you would have to familiarize with more details of this simplified certification paths to know if your customer could apply for it.
Okay, I have a question. How can I retrieve the QR code and pairing key for a Matter device during manufacturing when debug version is not used? The factor data only includes the discriminator and passcode. So that's true, but QR code and pairing key, those are generated based on the discriminator and passcode. So basically you can, since you are providing those values of discriminator and passcode, you can create QR code or pairing key, for example, by using chip tool.
Okay, we have some more generic question. So can we have a copy of your presentation file? Yes, you can. It'll be available with the webinar recording, but you can also click on handouts now and get a PDF version of that presentation. This is a similar question. Will there be a recording of the webinar available? Yes, it's going to be available. It's going to be on the page that you also signed up for the webinar. You can also find it in a day or two on webinars.nordicsemi.com/on-demand. And if you signed up with your email address, you'll also get a notification. And this is the same question. And then we have only one more left. And I think this is a really good point to our DevZone blog on testing Matter with different ecosystems. And I will try to find a link and post it in chat for that. Because there we go into detail on exactly how to do this, unless Łukasz wants to say a bit more about this.
Yeah, I think that the blog post is the best place to start with when you want to test your Matter device with the leading ecosystems. Can I control the Matter device from all ecosystems simultaneously? So it is possible to control your Matter device by multiple ecosystems simultaneously. This is generally possible due to presence of multi-admin functionality, where one Matter device may be commissioned to multiple ecosystems or Matter fabrics, while still operating on single IP network, like Wi-Fi or Thread network. But keep in mind that device needs to support at least 5 Matter ecosystems simultaneously. And product maker may decide to increase this number, of course, at the cost of requiring more memory. Then another question is, what programming languages are necessary to build a Matter device? I would say the combination of C and C++. More specifically, Matter stack itself and accompanying reference Matter applications are written in C++ language. And in addition to this, the NRF Connect SDK, which is based on Zephyr operating system, uses C language, for example, to interact with hardware peripherals like SPI, I2C, or to interact with OS-specific functionalities like timers or threads. Then another one, do I need to have an official device certificate to develop Matter products? So if you mean the device attestation certificate, the answer is yes when you release your product, and no if you develop and test your product. So our samples in NRF Connect SDK use the test vendor ID and development DAGs. So in general, you need a DAG to develop Matter product, but it is okay to have development or test version of it. This is enough to pass the Matter attestation process during commissioning against a simulated controller, which is a chip tool, but also it is possible to test your prototype device with the leading ecosystems, where there are currently 2 different approaches. The first one is where you need to create a development account and add your VID and PID of the tested device into the Cloud Console, which is the case of the Google Home ecosystem. Or the second one, where during commissioning, you will be informed that the device you are trying to add is an uncertified accessory. Still, even then, you will be able to proceed with the commissioning process and add such a device. This approach is taken, for example, by the Apple Home ecosystem. In general, I would encourage you to check our DevZone blog post that I mentioned during the webinar, where we have step-by-step instructions on how to commission and control such a Matter device, which basically uses the development tag. Krzysztof?
Yeah, so I have a very related question to what you have been discussing now, Łukasz. So the question is, what practical paths to Matter device development are open to non-commercial entities like education experiments makers and assistive technology developers? So as Łukasz mentioned, as long as you develop your product, as long as like a prototype, you do not have to apply anything what we have been discussing last hour. So all of that is really needed if you want to release a commercial product to the market and sell it. But as long as you want to develop, experiment, have a prototype, you do not have to worry about it. Another question is certification mandatory? And also a related question, I have products only in the industrial environment, usually through installers, but nothing in retail market. Does whole certification apply? Yeah, so I would say there are two aspects. One aspect is, as mentioned during the presentation, that some ecosystems may block adding uncertified device. The other aspect is around intellectual property rights. So there are some risks involved that you should consider, because typically certification provides a product license for intellectual property rights to the technology. And if you do not certify, your product may violate patents incorporated in a technology. So this is like an individual decision of every company. Probably something you can discuss with your lawyers and make an individual decision. Yeah, what is your approach to this risk? I think the next one is for you, Łukasz, about logs.
Yes. So the next one is, can we view Matter logs anywhere when using, for example, Google Nest Hub? So it depends. So first of all, certainly you can collect logs from the Matter device itself. It does not depend on the used ecosystem. When it comes to the Google Nest Hub, the ADB logs are disabled in production builds, but still you can check the Google's Matter VS Code extension, which provides some Matter-related logs.
We'll have an on-demand version of this webinar together with the webinar we had earlier today, and cut both Q&As together so you can see all of the questions and answers that were asked. Okay, and then thank you all very much for attending, and see you on the next one.
Thank you.
Thank you.